We are talking today about Gridlook, which was a collaboration by Max Planck Institute and DKRZ. Namely, Andrej, Tobi, Lukas, and me were mainly involved, but it's also an open GitHub project, so we have some contributions from all over the world. Gridlook is a data viewer for a system model output on an interactive three-dimensional sphere, which uses WebGL, which is a technology for nice 3D visualization. Yeah, you can follow this tech talk also via your mobile if you just scan the QR code or use this URL. Most of these visualizations will also work with your mobile phone or any other device. I am going to talk a bit before we look into the examples, because I am convinced that as soon as you open the first Gridlook link and it works for you, then you are distracted from this talk and won't pay any attention anymore. So we start with a bit introductory talk here. So it all starts with what Tobi calls an afternoon hack, with a bit of motivation for showing that it's possible to plot data without a high-performance computer in the backend. And also that you don't need compute servers in between the data and the actual visualization. But then it becomes pretty obvious that this can be more. And we now add some points to that motivation here, that Gridlook also allows us to interactively explore our system model output on its native grid. So we don't have to regrid first to some regular grids output. And also Gridlook allows us to share these views via an URL. So you can share URLs and copy paste it, send it to others, and they will have the same views on the data as you are, because there is no need for software installation. And for us developers, there was another motivation, this client-side rendering and the color mapping without an image pre-generation is kind of a unique feature of Gridlook. So we haven't found any tools at the start of Gridlook which were able to do that. So the design of Gridlook allows you to set up Gridlook for kind of any Zarr data set that is stored in cloud storages, cloud environment. The result is that you use the deployment of Gridlook, for example, here the Gridlook GitHub version on the pages, which is this URL, with an anchor, and then add just the Zarr URE endpoint for the Zarr dataset. And the Zarr dataset has to fulfill two requirements. It has to be openly accessible, and the storage where the Zarr dataset is should allow cross-origin requests, which means that Gridlook can fetch data from there as a middle client, let's say, or a little middle agent. So Gridlook is not a competitor to high-end visualization suites. So from a range of quick plots, monitoring scripts up to ParaView, I would say Gridlook is rather on the left side here on the quick plot scale. And it's also not meant for publication-ready quality graphics. It's built for intuitive, efficient, and interoperable exploration. Some technical details here. So there's a lot of JavaScript involved in the background, and the one key feature is that it runs with Three.js, which is also using WebGL. And when we scouted for other tools, we found some kind of similar tools, but they didn't use this rather complex WebGL backend, because it was considered to be too complex for this data visualization. But we found that it's actually pretty nice. Zarr handling is done via Zarrita, which is a JavaScript library for Zarr access. And over the time, we added some support for different grid types to support most of the model output grids that comes from our DKRZ users. This is here the range coming starting from regular grids up to the Gaussian reduced grids. So regular grids, are the long grids that most of you probably know. Rotated regular grids are often used in Cordex, which is a project for regional climate modeling. HealPix is something we look at in the next slide. Triangular is the typical icon grid, so the native icon grid, let's say. And then we kind of comprise everything that is kind of unknown yet as irregular grids. Gaussian reduced is the IFS native grid, for example, used in ERA 5. Gridlook is yet not able to display data from multi-dimensional arrays, so the 3-dimensional especially, so model levels are not enabled yet. You cannot see the scale. The Python example button is not working yet, and also the different codes and deployments are not really consolidated yet. And now we finally start with some examples. So the main effort that we did was providing support for HealPix and for therefore for all the data sets that were hosted in the hackathon in May, the World Climate Research Program Global Hackathon HK25. And in this catalog overview here, there is an icon from Gridlook for each and every data set, giving you one example view on the data set. So this was one initiative support for HealPix. And HealPix is what we consider here as a grid type. And here are 4 more links for HealPix data from icon, the Diamond 3 simulation, 6-hourly frequency, and instantaneous values. And I preloaded them here in the different tabs, and we go through them. And I think that maybe already shows you one use case of Gridlook for educational purposes. So what you can see here is how HealPix is designed. And HealPix is short for an hierarchical grid on equal area pixelation. So each of these pixels have the same area. This is HealPix level 0, so the entry point of HealPix, let's say, with what is it, 12 pixels, I guess. And this is already values of a variable that you can see. Maybe we can go through the panel here now. So this is everything you have to adjust. It starts with a drop-down menu for all the variables inside the data set. You have a time slider for the entire time series of the data and click around. So whenever you change this, then new data is fetched. And then the plot is updated. You can see the exact time stamp of the data and also, if provided, the long name and the units of the variable. And now the interesting part is, which I show you at the next level. So this is level 0. And if we go to level 4, we can see already that HealPix is hierarchical. So when you kind of divide the pixel by 2 and repeat this, then you get a higher resolution. And now we are on zoom level 4, so the higher resolution. And this here is zoom level 7. The main point, of course. So you have an interactive globe here in the middle, which you can drag and drop. It's kind of intuitive, right? If you find out that you can drag and drop this with your mouse, then it's pretty easy to use for anyone, I guess. So you can zoom in with the mouse roll and zoom out again. You can also toggle the rotation, and that means that the Earth starts to rotate. And this is pretty cool. So changing the color map. So, and this is astonishingly fast every time I look at this. Maybe we use another variable here, surface temperature. Perfect. Because I'm a bit more familiar with that. So we can change the min value and max value of this. and arrange it more to, for example, Middle Europe here. And then we can see that the rendering directly works within the browser. We can change the color maps also to something different if you like. Yeah, invert it. And also take out the coastlines if we want. Okay, then there's a snapshot button for PNG graphic that you can download. And this Python button here unfortunately does not work yet, but yeah, I guess that's something for the future. Okay. And astonishingly, Gridlook also works for the very high resolution data. This is zoom level 11 precipitation. And if we now adjust the max value here, then we can see some structures from this model simulation. Yeah, here are some precipitation bands, frontal structures, I guess, and a lot of convective precipitation, I guess, in the equator region. And yeah, so once it's loaded, it's very fast and interactive. So it doesn't hang or something. I think the technology works pretty well. Yeah, but zoom level 11 also downloads a lot of data. So I think it's about 500 megabytes, depending on the variable and the compression. So yeah, you have to be careful if you use your mobile phone at this point and you're on the mobile network, then you probably have to pay for more gigabytes. Yeah, so maybe focus on the low resolution at that point. So all right. Now we are going to look at the other grids. For that, I am switching to this. Okay, starting with the triangular icon native grid. So this is an example from ERIES, the historical simulation on a 10-kilometer grid. And we are looking now at temperature. And if we zoom in here, we can see the triangular grid structure. Yeah. And opala. I mean, if it is a bit interrupted, then it could probably be due to the zoom, I guess, sharing through Zoom. You can also use the arrow keys here to navigate around the Earth on your keyboard. Yeah. So the icon native grid is also supported by Gridlook. Then we have an example for regular grid, the lat long. In this case, this is a CMIP6 example on 30-kilometer resolution precipitation. So we have support for CMIP. It's from EC Earth. And also here we can zoom in and we can see this rectangular grid. Yeah. And depending on the regular grid, you might have a hole at the pole, but this is, yeah, because we are plotting the center grid points and not the boundaries. And then we have an example for a rotated lat long grid from Remo, which is used, yeah, for the Codex project. So this is the Euro 11 grid temperature on the historical experiment. And yeah, that shows you that Gridlook is also able to display not global, but regional data sets. Also here we can zoom in. Yeah. Interestingly, so it starts from red to blue here. So we have to unclick the invert, and then we have it in a better color range here for temperature. So blue means now cold and red means warm. All right, further Gaussian reduced. So there is already an early implementation of support for the Gaussian reduced grid, which is kind of similar to a regular grid, but the longitudes decrease towards the poles, so we have less longitudes when we going to the poles. And the example here is from IFS, 10-kilometer output, also from ERIE. And yeah, what you can see here is that in this implementation, we still have some black dots, which yeah, arise kind of randomly. But we take that into account because we still have a very kind of valid visualization of that grid. So it's nothing interpolated or something. It's just really the grid point here that you see is really from the data. And this is wind speed. And so what I see here is that at the coast we have some suspicious values. So this is something where I think Gridlook can be maybe used for. So investigating some model specifics and yeah. So what I mean is these strange rectangulars here at the coastline. Yeah. Okay. And last but not least, irregular. So for everything else, we have an implementation that just similar to a scatter plot, just plots the points which are associated with a lat and long coordinate. And this is an example of the Fesam grid. Yeah, CMF6 contribution temperature of the surface of the ocean, sea surface temperature, genau. And yeah, in Fesam we, depending on the resolution, can kind of see eddies if we also append the time scale here. Okay, something like this. And we can zoom in and see it's only points that overlap a bit. And yeah, this unstructured grid has a higher resolution in specific areas and less resolution around the equator, for example. And this should be the fallback solution for Gridlook for all the other grid types that it is not yet able to identify. All right. Yeah, so aside from educational purposes and model bugs, what I see as a pretty nice use case for Gridlook is that we can look at the highest resolution of the model and therefore kind of understand the real model internals. And if you click here on that link, then we are looking on the highest resolution of IFS, and you would see, if you go to the precipitation, something like this, kind of circular shapes of precipitation. And it's likely that this comes from just how the model is set up and developed out of the, And of course, through the Zarr datasets, and also Gridlook here as an example, allows us to build nice web apps, and we could also include Gridlook in other web application. And if you have your mobile phone here open for this tech talk, you can see that it works. And I think that shows the potential of the technology. All right, this here is a nice picture of cloud cover of the highest resolution of IFS. So if Zoom doesn't give you a nice view yet until now, so this should be able now to to see all these features here of Gridlook. So this is a picture made by Gridlook of cloud cover in IFS, and you can see the different structures, different types of cloud. This over the Pacific, I guess. Yeah, right. And there's also a link to a video, which I'm not showing now. So Gridlook collections, as I said in the beginning, we can just append an URL to the Gridlook deployment, but we have also some collections of these links. And one idea, one test setup here is by just adding an asset in a stack catalog. So this is all prototypes and kind of a test service for the Diamond 3 output that was used in the hackathon and that was stored at DKRZ. We have this catalog here. And if we click here through the entries, so these are all collections. For example, this icon R2B10 Diamond 3 August simulation, and then we go to a specific, maybe this one. item. So this is kind of a data set that you can open with Xarray. And we can append here an asset with a button for Gridlook, and then you click on that, and hopefully this works. Yeah, perfect. So this is cloud atmosphere mass content of cloud ice for this particular simulation. So this would be one idea how to support Gridlook within DKRZ services. And for this hackathon, we did set it up. And this kind of works pretty well for this data because of two main reasons. So one is that this S3 cloud storage, which we used as a test case here, was really performant and gives an overall nice, efficient response, I would say. And also DKRZ helped in the preparing of the data sets. So we rechunk data, we enrich data sets with attributes and some variables that are needed for Gridlook. We brought it to the cloud, and we also embedded the links in the catalog. And this is kind of an insight into the Gridlook GitHub repository, where you can see the activity, how many visitors we had and how many clones. And it shows you that during the hackathon, which was in May, we had a lot of activities. It was mainly because Tobi made great advertisement in Japan. And we had this links in the catalog, and it was used during the hackathon. Unfortunately, this increasing curve here doesn't increase anymore. So this is why we make more advertisement. You can also use sources of other cloud storage providers. I don't want to hide that information. It's pretty clear from the usage of Gridlook. So the result here would be find the downloadable .z metadata of the Zarr dataset, copy that URL, append it to the Gridlook URL, and then just remove the .z metadata and submit. And I give you here some sources from Google Cloud. Google Cloud and Amazon, they have large amounts of data in the cloud, Zarr data sets in the cloud for CM6 and Cortex. So feel free to test that out. If you want to make your data set plottable with Gridlook and bring it to the cloud, then I also have here a minimal guide. So for identifying the grid type, we need some information, and the best approach would be to make the data sets conform to the climate and forecast convention, which is linked here. This would also allow us to identify the grid type. So for example, if you have a rotated lat long or a helix grid, then we need the grid mapping attribute. And coordinates are also often used, latitude and longitude values. And this is a kind of specific of Zarrita. Maybe this will change in the future. So we have some problems with the interpretation of time if it's encoded as integer 64. So use some other type like float. Long name attribute would help to show more information in Gridlook. The second step would be bring it to the cloud. So up to now we support and recommend Swift until the end of this year. And in near future, there will be support for S3. So for example, you could use CDO to copy it to a Zarr data set with this -f and C4C, and then upload the output to a bucket in Swift. You can also do that in Python without the temporary output by using Swift spec and Xarray. And we have an example notebook from the ERI hackathon. And in the end, step 3 would be setting the bucket to openly access and also allow cores by adding this metadata field here. This is just copy and paste for you. And if you want to optimize the data sets for web apps, here are some tips. So it's all about reduction of the amount of transferred data. And for that, you have to look at the chunks. So chunks is the binary data of the Zarr data set. And there are some sizes of chunks that are better for web apps and sizes which are not optimized for web apps. And one good approach would be to keep it small in the range of 1 to 5 megabytes. And those chunks can be cached in the browser, and that means also in Gridlook, if they are smaller than 50 megabytes. They can be loaded in parallel, and then it's kind of performant. And you can also compress the data and the chunks. And Zarr supports different algorithms for that. All right. Outlook. So here you can see activity of Tobi in Japan, in Tokyo. Tobi, do you want to say something about that, maybe?
I can. I mean, they have this fine, nice spherical display, which is basically just a projector behind a spherical screen. And to support that, I implemented the azimuthal equidistant projection, which is basically the projection you need to show the map properly on the projector. Actually, in this photo, this projection is not yet implemented. That's why you see like this black arc at the back side of the projector. But in a later iteration, yeah, we had that properly implemented and can use then Gridlook to visualize data on that screen.
Yeah, yeah, it's really cool. Yeah, yeah, maybe in the future would be an idea to buy some of these things. Yeah. Yeah, so there are kind of some what I would call low-hanging fruit. So things that we will implement because we kind of also have the need to. For example, yeah, sliders for additional dimensions. It's kind of a pity if for multidimensional arrays Gridlook is not working while we have the technology, yeah, to kind of easily implement that. And also what would be nice is to have a kind of config via the URL for the variable that is shown or the color map that it should be used. And yeah, that would be nice. But for more, we would really need support in the development of Gridlook. And here are some ideas that we just propose for Gridlook. So it would be really nice, don't you think, to have the Python button working again? So then we would have a reproducible workflow for generating the same images in Python, similar to what you see in the browser. Also pretty obvious, it would be nice to have a play button for the time series, which of course would then only work for smaller data sets, but at least that would be nice, right? We would have like videos for that. Yeah, and of course, if we want to make it even more interoperable for more data and more grids, we could think of making it a tool with a data serving mechanism or supporting more complex grid types. And there are ideas to make it even more efficient. But yeah, for that, we definitely need more support. And I think with that, I thank you for your attention. And we have the Gridlook GitHub URL here where we can discuss and raise issues. And I think Gridlook, in a nutshell, makes climate science more explorable and tangible. And yeah, there are some outtakes.
Thank you, of course, Fabi. Most of the questions have already been answered. One is being typed, but one of the questions is, will the slides be available after the talk?
Yeah.
You can put them in the event if you want.
Yeah. Yeah, it's all markdown. I guess we will reuse it in, I don't know, in GitHub maybe. That would be a nice location, I guess.
Okay, so yeah, then we should put something. If it's a link to the GitHub, we can also put that in the event where you signed up, and then you can find the slides somewhere from there. Can you give a demo of the process if time permits?
Of the process of what?
Yeah, that's a good question.
I think we have some time, so.
Is it possible to display one variable from two datasets, for instance, from reanalysis and a simulation side by side? Oh,
Not
okay,
yet.
someone is answering already.
Yeah. Well, it would be a nice add-on, like to have 2 globes or something. Would be really nice. But not yet possible, no. But I think pretty, yeah, implementable, let's say. I would love to answer this question about the process, but I would like to know what it is.
Just a quick demo of the plot of a variable. Sorry, I'm new to this. Okay, a demo of a quick plot of a variable.
Mm-hmm. Yeah, that sounds like a question to Andrej. Here?
Or maybe it's just elected.
I release the senior developer and let him answer in full detail how the variable is plotted.
Actually, it's different for every single grid. I mean, so most of the triangular data is so like icon is plotted. So we essentially just plot triangles based on their coordinates, and for the Gaussian reduced one, we plot two different triangles for one grid cell. And the irregular data is just a point of clouds. Sorry, the other way around, a cloud of points. Because we don't have any, so it's quite hard to find out the information how large a cell is, and therefore we just plot points. And in this particular example, we have some heuristics enabled to make the points bigger when they have when they have less neighbors. And the more neighbors they have, the smaller the points get. But this is just a heuristic. So especially the irregular grid is work in progress as of now.
Would there be something that you as users wish Gridlook should be able to do? So maybe we collect some a wish list or something, like things that could be implemented.
Yeah, so if you have a GitHub account, feel free to create new issues if you have wishes for new features. There are already quite a few issues. But you're welcome to create new ones. Regarding the answer, which I just see is being written, this Gridlook. So Fabi was using a customized version of Gridlook in his examples. This is for example, the Gaussian reduced grid is currently not implemented in GitHub. It's just it's in the testing phase, and the link which is being posted there, this gridlockpages.dev link, does, for example, not support Gaussian reduced as of now. But yes, we're working on it.
Would it be possible to add a filter by time feature? For instance, to show only certain months or seasons.
Yeah, I think for these very large data sets, this rather small time slider is not optimal. So I agree to kind of optimize that a bit. I'm not sure about how, so I'm not sure about the best approach, but that could be one. Kind of, yeah. Presetting kind of what you want to see, right? So yeah.
Would it be possible to plot unknown grids with a spherical Voronoi diagram?
I briefly tested it with a Voronoi. It's so as I said, I just tested it briefly, and it was extremely slow. Much slower than the point clouds, but this is maybe something for the future. We also tested Delaunay, which is kind of in use in the current implementation, which Fabi has shown, but not for creating triangles. Yeah, but Voronoi especially is quite slow.
Are integrations of other formats than Zarr planned? For example, an integration with the OGC API coverages standard would be interesting. And then there is an example link that you already opened, right? Yeah.
No, it's not planned, but we haven't really talked about it or thought about it yet. So yeah, thanks for the point. And I mean, the central technology is Zarrita, so it all is based on Zarr, but Zarr is also kind of compatible with other formats. So maybe we find some solution for integrating more.
Can this tool be used for netCDF data?
Maybe via CareChunk. There is an implementation in Zarrita for CareChunk. But it has to be in an open cloud storage then. So it has to be accessible similar as a Zarr dataset. But yeah, we would have to discuss a bit how that would work. Well,
I mean, maybe I can add also to that the initial idea was to show that if data is organized nicely, then it's relatively easy to make a plot in a reasonable time using limited resources. That was the purpose of this thing. And so naturally, we don't aim to cover all the variants where data is organized in a shitty way. I mean, maybe that's mean to say it like this. netCDF has its nice sides also. Yeah. But yeah, one idea was to not have the need for a server to reorganize the data for you before you can plot it.
I don't see any more questions. Then let us thank the speakers once more. Yeah, thank you, Fabi, and the rest, Andrej, Tobi, Lukas, and see you with the next Tech Talk.